Hello, this video is about how the training has been done for the Namaz posture recognition system. So for the training purpose and extracting the train model for that system, we have used the IBM Watson Studio cloud services. So basically our model is cloud-based and run on internet. It's a deep learning based model which is basically trained on the IBM site servers, and then we access that model with the help of the credentials. So let's see how we basically start with the IBM Watson Studio. So first we will give our username and password. So once it has been given, you just log into it. So after logging in, you will see that dashboard. So for training the model, first we have to register a server for the image processing and computer vision things. So you can see that we have taken the service of Watson Vision Combined PS, which is basically they have allotted a server to us, which is based on the Dallas. So after this, we will create a project on it, and after creating the project, we basically train our model. So let's first look at our project, which is a Namaz project. Okay, so you can see on the right in this area we basically upload our trainings data into it. We can upload either the single images, or we can also upload our images in a zip file as well. So this is the file we have uploaded it, which is train.zip. And if we move down, we can see many things like new collection, which is basically our Namaz poster recognition model. You can see the model ID here as well. So let's go into it. So once we go here, we can see the summary and objects here. We can see the test and implementation side as well. Let's wait for loading. Okay, here you can see all the details related to the models, and here you can see the number of examples has been used for training as well. You can see for Qiyam, Ruku, Sujood, and Tashahhud. So here we can also test our model online with the threshold as well. So let's upload one image here related to our datasets. I am uploading the number of test images here, and you can see the results as well. Let's set the threshold to the 50%, and here we can see the detected objects. Now, how the implementation has been done, we will explore this. So for seeing for observing that how the implementation has been done, we will go to the API specifications. So here we have used the Python code to extract our model. We can see here when we can go to the Python. So these code has have been used for our model extraction. So this is the authentication code, which you can also see that has been used in the main code as well here. And then we have basically used there another code just below, I guess. Then we have used this code for extracting and predicting the labels against the image or frame. We can see this code here as well. Now let's move here again. Now, how the model has been implemented. For this, we basically need credentials. So for credentials, we will go to our associated service or the allotted service, allocated service by the IBM Watson, and we can see the credentials here as well. So these are the credentials we have used. We have used the API key, we have used the URL, and we have used the collection ID of the model. In case if we have to, we can also um, um, make the new service for us for the new model, for which we have to go to the Watson services, and then we can add a service here. For adding the service, you will select on Add Service Plus on your right side. And here you have to basically select it, which service you are looking for. So since we have uh, trained our model on the visual recognition service, so we will click on it. And now we will request IBM Watson to allocate the server for us. So here you can also select the region. We have selected the Dallas region for us, and we are using the light version. It has a paid version as well, in which basically you can do training up to the 1 lakh images, and also you can make many custom models. In the light version, they only allow 2 custom models to be built. After doing all the configuration, you can just click on create to create your new services, and then you will get the credentials for it. Let's now move towards our projects again and see that how the training has been done. Alright, so let's move towards our Namaz project again. Now we have to click on the edit and retrain. Once this has been loaded, then we will click on it. So we'll click on edit and retrain. We use this thing, the model ID in our collection ID in our configuration, which we can see here as well. The collection ID, the API key, the version. The version must be the training date of the model. That's when the model has been trained, and the URL and the collection ID. So let's move towards our edit and retrain. So here we can see that our uploaded models are uploaded pictures are here. We can just click on any picture. We can start from it. And here we can see all the labels we have assigned. So labeling any objects is very easy. For example, if you have to assign any object to it, you can just click on the add objects. You can just make a rectangular box and just name it whatever you want. Let's say we can name it as Roku. So it will add another label here. All right. So once we done with all labeling, since the labels has been done and the annotation has been provided. Once we are done with all training, we just click on the train model. So it's a very easy GUI process. When you will click on train model, the model will start training. And once the training has been completed, the notification will show here that your model has been trained. So now you can easily extract the model from their collection ID and the credentials of your services. So it's a very effective technique. For example, if any further retraining required, so we can retrain our model on the cloud. So if there is any any change happen on the cloud with the model, so automatically the change will also observe on the device as well. For example, if a person using the Namaz recognition system, machine, and all the things in, let's say, in USA, and I'm here in Pakistan, and for example, he requests me to train some more data in it and improve the accuracy. So what I will do basically here, I will add some more examples into it, and I will retrain again. Once I will retrain it, then when he will run some model, he will see the improved results because of the cloud engineering have been done here. So this is all about the IBM Watson services and the cloud deep learning model. So if any question are required, so I would love to ask them. Thank you so much.
Start.
Hi, this video is based on the explanation of the Namaz posture recognition system. So we will explore the three files which have been used in the Namaz posture recognition system. We will first start with the z.py, which is basically based um, on Raspberry Pi file getting the data from the camera module and then do um, run the deep learning model on it and then pass the data to the Bluetooth video. So we will first start with the library. The first library is known as CV2, which is the computer vision Opencv library for the computer vision functions. Then we have another library named as threading, which is not used in the program, but in the future, if we want to do the multi-threading, we can use this library. The other three libraries are related to the cloud model, which is based upon the IBM Watson Studio. So these are the important files which is used to deploy the model from the cloud. Then we have another library known as time, which is used to calculate the time lapse in the function, and then the serial for communication development. We have now a function named as port, which is basically
we are creating objects by passing the baud rate 9600 and the RF form 00 for the Bluetooth module XC05. The things in the comment we can ignore it. We will be using the functions step by step in the while loop. We first authenticate our model uh, with the Watson authentication function, in which we basically authenticate and communicate over Raspberry Pi with the IBM Watson cloud model. So let's explore the Watson authentication function. So in the Watson authentication function, we pass the API key, version and wallet are the credentials, and after passing it, when it gets authenticated, it prints the message as well and return the visual recognition object. After this, we have another function named as cap.video capture, in which the video address has been given. You can use it if you want to run it on any recorded video, then you have to comment the next one. Otherwise, if you have to run on the Pi camera, then the latest frame is this. Uh, this is the image file has been used to save the every frame, because the IBM Watson model only takes the file in the .jpg form. So we have created a file here in which we will, or every time we will write the same file with the same name. The next line explains the FPA of code. FPA is the name of the camera. Then we have a here of the 4 elements, and then we have a max portals, which are the root, and we can ignore the int because it right now we use the program. So let's start the loop here. First, it takes the initial value from the start, and then it's read the category, then it's resize it to 320, then it's putting it with the name of the image file. After this, we will go towards the result, in which it's basically get the prediction from the IBM Watson model. We are passing here object of visual recognition and object of the past from IBM Watson, and we are passing the collection ID, which is related to the deploy model collection ID, credentials, and the image file address. Let's go to the get result. So in the get prediction functions, we are basically opening the image file first with the path, and then we are getting the result from the visual recognition analyze function, in which we are passing these 3 parameters in the result JSON format. After getting the result from the JSON format, we basically extract the 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 identification that whether the object has been detected or not. If the object is not detected, then it will just pass the frame. Otherwise, it will store uh, the the values or the information of an object into the outcome, and then we get single score and single label from this. After this, we print the label and score the confidence score, and then we pass through the window. So how this window works? So this window works in the first and last of method. So we're in this function in the whiteboard. So let's say there are indexes 0, 1, 2, and 3, and in the first 4 frames, the poster QIAM has been detected. So, for example, now if a Raku has been detected, so what will happen? So the Raku will come here, and it will push all the previous elements to the next. For example, now this Raku will come here, this Raku will come here, this this QIAM will come here, this QIAM will come here, this QIAM will come here, and this Raku will come here. So eventually it will become R Q Q Q. Now, for example, if the Tashud has been detected, so the Tashud has been come here, the Gu will come here, Qiyam will come here, and this Qiyam will come here. So it will be like Tashud, the Gu, Qiyam, and Qiyam. So first in and last out. Let's move towards our code again. It's pass the Windows data to the Bluetooth send data function. How the Bluetooth send data function works? Let's see. So the Bluetooth send data simply takes the window, it sets the value data to the 10. So it checks the two things. First, the count of the posters, the number of posters should be 2 in a window. And also the first two elements should be the same. For example, if the qiyam has been detected in the real time, then in the window the qiyam should come twice and on the first two positions. Otherwise, we will not detect it. These parameters has been cued and set according to the real-time scenarios. So it's passed the data 20, which is mapped to the vibrations of the qiyam thing, and then passed 30 for the ruku to the Bluetooth, through the Arduino Nano. It is Sajida for 40 and Sajida for 50. Otherwise, and then after setting the data, it set the data to the string and write the data, transmit the data to the XC05 Bluetooth module, which is further connected to the Arduino Nano, and then if it's received, then it's received the function that the data has been transmitted. We have now another function after the Bluetooth send data. So let's see. So the object has been detected. After detecting the object, we have already sent the data to the Bluetooth module as well. Now let's come towards the visualization on the camera. This step is um, optional if you only want to get the signal on the receiver data and not want to visualize on the Pi frame, then you can exclude this. You can exclude. All right. So it's basically takes the bounding box of the image. For example, if someone has doing the qiyam posture, so it will draw the bounding box around the person. It gets the initial x and y values and the width of the bounding box and the height of the bounding box, and then it um, gives the all the things as a parameter to the generated results function. Let's also explore the generated result function. In the generated results function, we are basically passing the image in array. I think there is an image path has been written in your program. You can change it to the image, and then it is passing the confidence score and the label and the bounding box information. It sets the font. If there is a qiyam, then the red bounding box will appear, green for the sujood, yellow for the ruku, and blue for the tashahhud. Since the qiyam and ruku are standing position, so for this one, we are basically getting the annotations of the confidence score and label on the right side. Otherwise, for in the case of sujood and tashahhud, we will get on the top of the bounding box. The confidence score is less than 0.4, then it will label it as unknown. All right. Then it's basically takes the confidence value to the up to the two floating values with the two decimals, and then it's write the final text and we draw the bounding box here. Then here we basically put the text on the bounding box, and it's return the image again. And the returned image is basically shown as the frame on the Pi frame in the Raspberry Pi. Now, if the object has been not detected, then it just only show the the frame on the window. After that, we are basically taking the difference from the current time to the start time to get the time lapse and print it. In this function, if the Q key is pressed, then it will exit from the processing. After that, it's released the camera. It may turn off the camera, and in the destroyer windows, it closes the frame window. Let's come towards our next function program, which is enabled H05. So this program must be open in the separate terminal in the Raspberry Pi. It means that Pi should be run in one terminal and enable H05 should be run in another terminal. the Raspberry Pi. It should be run continuously. It should not be closed. It just have the physical address of the current Bluetooth HC05 module, which is connected to the Arduino Nano. If you want to replace the Bluetooth module, then you also have to change the physical address as well. It's just pass the command line function sudo rf connect HCI0 to the physical address one through the OS system library of the Python. So from the Python script, we are basically passing the command line function to the terminal. It will start the Bluetooth communication with the HC05. Then we have the receiver side program, which is known as Bluetooth receiver. We are basically setting the constants here with vibration pin at the pin 4 and melody at pin 12. Similarly, the QHN Sajida at 8 and 6. So Qiyam melody is regarded as red LED, the Ku is as yellow, Sajida as green, and Tashuda as blue. We have two functions here, blink LED and vibration, which we have defined and declared here. In the setup part, we are basically setting the portrait to the 9600, and here we are setting the Qiyam pin mode of everything at the output. In the loop section, it's first listen the data from the Raspberry Pi, and it's first see that if the data has been transmitted or not. If the data has been transmitted, it's convert the data into the numbers. And after converting into the numbers, it's see that if the value is greater than 0, then it shows that your input is that thing, and it passed the integer to the blink LED function. In the blink LED function, it see that if the past value is 20, if the past value is 20, then set the Qiyam pin high, we can see that we have passed. Let me get to that function. We see that we have passed 20 in the when the Qiyam has been detected. So when the 20 value is passed, the Qiyam LED will high, other will be low, and the vibration will be set to the 300 milliseconds for the one time. The vibration function is here. The vibration function is simply taking the delay time and the loop counter. So we are setting delay time to the 300 milliseconds and loop counter to the 1, 2, 3, 4. For the Raku, it is setting high LED, Raku LED is high and other are low, and vibration are set to 300 milliseconds for 2 times. For the value of 40, you can see that 40 value is mapped to the Sajud. So for the Sajud, for the 40 value, the Sajud pin is high, other one is low, and it's set to the vibration to the 300 milliseconds 3 times. Similarly, for Tashud, setting vibration for 300 and 4 times, and only Tashud LED is high, other ones are low. So this is a description of complete system of the software programming of the Namaz poster recognition system. If there is anything required to be asked, so you can ask me any question anytime. I would love to answer.